I'm Giusy Tomarchio, working for STMicroelectronics in system research and application.
Thank you. Could you tell us what you're demonstrating here, please?
Yeah. We are talking about condition monitoring and predictive maintenance. ST has a strong commitment for industry application, and predictive maintenance is one of the most promising applications in this world. Within ST, we have products that cover sensing, processing, and connectivity. So we are able to provide a solution that can help customers to improve their machine condition and improve overall efficiency and so on. So if you follow me, I can tell the story of the pod. So here we focus just on products. You know, ST is investing a lot of industrial sensor and as well to connect with with all the needed connectivity in the industrial world, from wireless to wired and so on. If we move on the demo that we are preparing for vibration and ultrasound monitoring, basically we are demonstrating how putting some sensor node close to the equipment the customer wants to monitor, we can detect vibration and ultrasound. Vibration and ultrasound are characteristic signals that appears when condition of the machine are deteriorating, and with our sensor we are able to capture this data at the right time when it is needed. And according to the different scenario of industrial playground, we can connect or wired. We have here a demonstrator with IO-Link, for example, or we can connect wireless. And here we have a prototype of a wireless sensor node. The concept here that we are showing up is we have different kinds of motors. Actually, in the booth we have two small motors with the actuation and one big motor that is actuating. As well, we have two remote mode connected sensor in Catania, actually, and we are able to connect all these nodes, detect the condition of the vibration, and monitor if they perform well or not. On top, we are connecting all these nodes through cloud, and we have prepared a dashboard where very easily we can check the status of the various nodes. So if it works well, you will find green. If not, you have a warning signal. This will be detected with the yellow. Otherwise, it's red. Red means you are very close to something happen. So get in to maintain. Yeah.
Be careful.
Be careful. Yes, exactly. And particularly interesting is the ultrasound monitoring because ultrasound appear very early when something is moving on. And here particularly we are representing some pipes where if you have problems, the ultrasound appear and you can detect it through this wireless node, understand the frequency, where it appears, what is the amplitude and so on, and convert it in a warning signal.
Can you show us what these two sections here are demonstrating?
Yeah. So basically, as we are reproducing an industrial environment, we are covering mixed situation where you have big motors like this. This is 15 kilowatt motors. Here we are monitoring the vibration thanks to this reference design. This is an industrial integrated sensor with sensors, accelerometer, and microcontroller. This is detecting the vibration and sent through this connection that is based on IO-Link on the master board. And here we are connecting small motors, other two motors. So big motor, small motors connected to a gateway and send data to the cloud. We are handling different solutions. If you see here, it's interesting to see that ST is able to also power drive these motors with different power. We have here this solution that is an ACEPACK power module, able to drive up to 30 kilowatt and so on. While here we have small motors with another evaluation board that is able to drive this low voltage motor. So in this scenario, we demonstrate how ST can drive and condition the machines.
What are the typical end applications for these products? What what sort of specific industries would they be for?
Well, this can be applied to different industries, but let's think about, for example, ST fabs. We have a lot of motors inside our fab for pump, because we have water, we have a different kind of chemicals and so on. Inside our fab, for example, we have hundreds of pumps. If we are able to retrofit and connect all these pumps, we can monitor very early, and instead to campaign maintenance, we can make maintenance when it's needed. Thanks to our sensor, we can detect the right signal at the right time, anticipating the maintenance, reducing the cost, and increasing the throughput of the machine and so on. So this can be one of the examples we can provide.
That's absolutely great. Thank you so much.
You're welcome. Thanks to you. Bye.